Today is the 27th of September 2023, and this will be our third lesson on angle. Okay, and we want to look at alternate or Z or Z angles. Okay, it depends on how you pronounce it. Now, before I start the lesson, thank you to everyone who has been watching our videos. Okay, please, I will encourage you to subscribe, share, like, and follow us. Okay, if it's not your account, please ask for permission from the account holder. And please follow my notes/scripts. I normally put this in the comment section. Okay, this is very handy for what we are doing, because if you just watch the video, you wouldn't know what angle I'm referring to. Here, angles is in degrees, not in degrees as temperature, but in degrees as in angles. Okay, so like today we are going to talk about alternate angles using the parallel lines, and I would like you to follow the notes. Okay, thank you very much. Beware of scammers. Okay, I shouldn't say a lot on this. We all know it's happening. Okay, don't allow people to gain access to your account and then start sending you strange messages. Okay, because I don't do that here. Okay, we don't do that. We don't ask for money online. If it's not in the video, then it's not us. Okay, if it's in the comment section, I'll delete it anyway. But assuming I haven't seen it, please don't assume it's not us. Now, recap from the last lesson. I helped you use the protractor to measure angles. Okay, this is one. Okay, in case you haven't watched last video, and I think there was a video also that I used the protractor as well, the pie charts. Okay, so I'm assuming you have started using the protractor. Okay, so just do practice. Math is practice, and you will get it. Okay, so we measured angles. We looked at vertically opposite angles, and we used angle at a point theory. So the angle at this point is 360. So this is a vertically opposite angle, but even if it's not vertically opposite, ABC should be equal to 360 degrees. Okay, so if you've been given A and B, you should be fine. You should be able to find C. But what we did yesterday was slightly different, where we look at vertically opposite angles, where we said A equals B and C equals D. Okay, because if you look at this angle here, so if you've been given A, you should be able to find B, or if you've been given A, you should be able to find B and use B to find D, and then this C and D are also equal, because B and D are on a straight line. So 147 add 133 should be equal to 180. So if you know this, A, you can find B. You can use B to find D, and then because D and C are equal, you can find that. Okay, so this is what we did yesterday. So I have an example here again. Here, if A is 47 degrees, then B is also 47 degrees. So we've been given A. So from what we learned yesterday, A is 47, B is 47. So A is 47, B is 47. Now, this angle at this point is 360. Okay, so 47 times add 47 is 94. If we take it from 360, we have 266. If we divide 266 by 2, we have 133. Okay, so this is what we did yesterday. Today we are going to build on that. Okay, today our starter is dividing fractions. Okay, so we have two fractions and they are dividing. We know that the first fraction, we repeat it, and immediately we bring the multiplication sign, we flip the fraction, 9/7. We've done a video on that. So now we can multiply the numerator and multiply the denominator. So we have 1 times 9 is 9. 2 times 7 is 14. Now another example here. 2 divided by 3. 2/3, that is our first fraction, divided by 5/8. So because the division sign, we need to flip the second fraction. So 2/3 times 8/5. Without flipping and multiplying, we can't multiply. Okay, we can't do 2 divided by 5 and 3 divided by 8. That's not how we do fractions. Okay, so now 2 times 8 is 16. 3 times 5 is 15. Now this is a top-heavy fraction. We can leave our answer here as 16/15. Okay, but if they ask us to leave it as mixed number, then we'll go ahead and have one whole number, 1/15. If they ask us to leave it as decimals, we'll have 1 point something. Okay, so it depends on what they want us to do. But if not, this is our answer. We can leave it as a fraction. Now, this one also, 3/4 divided by 1/6. Okay, so 3/4 times, immediately you bring the times, you need to flip the second fraction. So times 6 divided by 1. 3 times 6 is 18. 4 times 1 is 4. Now, if you have 18, you have 9. If you have 4, you have 2. You can leave your answer here as a top-heavy fraction, or you can go ahead and put it as a mixed number, or maybe in decimals. Okay, if not, if it's under exam condition, I will leave and they haven't said anything about how I should leave my answer, I will leave it this way. Now, another example here. Our last example for a starter. So 5/8 divided by 3/4. So 5/8 is the first fraction. We repeat it. Immediately we bring the multiplication sign. We need to flip the second fraction. So the numerator becomes the denominator, and then the denominator becomes the numerator. Okay, now we can multiply. So 5 times 4 is 20. 8 times 3 is 24. Half of this is equal to, not take away. This is equal to, not take away. Okay. Half of 20 is 10. Okay. Half of 24 is 12. Half of 10 is 5. Half of 12 is 6. So our answer will be 5/6. Again, if they haven't said anything, I'll leave my answer as a fraction. Okay, so this is a quick recap on dividing fractions. Okay, because we've made videos about adding and subtracting, division, and multiplication of fractions. Okay, so you can go and have a look. But I just thought I'll bring a starter because a lot of students have issues with remembering this. Remember, the first fraction remains the same, but immediately you bring the multiplication sign, you need to flip the second fraction before you can multiply. Okay, now let's get on with today's lesson. Yesterday we did vertically opposite angles, and I'm going to show you, but today we want to consider parallel lines. So if you can see, from my introduction to angle, the first video, that is a parallel line here. So it's like the end of one road, or if you take two roads together, the end of the two roads. Okay, so assuming this is a road and a car is traveling there, that is one end and that is one end. Okay, the arrow is going this way, so it's parallel. Okay, all it says is it's parallel. We want to look today at alternate or Z angles. Okay, I'll tell you why they call it Z angles. So if you look at this diagram carefully, after the parallel lines, I've drawn a line straight across. Now you can see your figure Z here. Okay, there. So here, A here and A here are equal. I want you to watch the figure. This is where you need to follow my notes. Okay, so A degrees equals A degrees. Now look at it carefully from what we done. Assuming I cover this side. Okay, I cover this side. Okay, from yesterday's video, the top part here, assuming I use this to cover this side, what do we get? What we saw yesterday, vertically opposite angles. Okay, so yesterday we had one line and then we had a cross. Okay, so we said, if you can watch, this angle here, A, will be equal to that angle here, and this angle here will be equal to that angle here. That was what we did yesterday. So we said the angle at this point is 360. So this is A, that is A. And then when we take this, that will also be equal. So if you add A to A and you take it from 360 and you divide by 2, then it's equal to these angles here. Today, we've added another line which is parallel to what we did yesterday. So all we've done here, this is what we did yesterday. We've added another parallel line. And then we've managed to find this Z sign. Okay? And we are saying that this A here and A here are alternate angles or Z angles because they look like a Z. And A are equal. Okay, so from what we learned yesterday, okay, if I know I've been given this angle here and I'm asked to find this angle here, I can use this angle to find this, and whatever I get for this is equal to the angle there. Okay, so keep that in mind. Now, the figure forms Z angles called alternate angles. So these A and A here are called alternate angles. Okay. We connected to yesterday's video of vertically opposite angles. So I've shown you that assuming I cover this part of my figure, then this is what we did yesterday. So this A here equals A here. So my angle at this point, all these four angles should add up to 360. So this A equals A. Whatever I get for A, I'll take it out from 360 and divide by 2, and that will be these two angles. But assuming they didn't ask me to find any of this angle, and they bring two parallel lines, okay, and I'm asked to find this angle, or they gave me this angle here, then if they give me this angle here, I can use what we learned yesterday, vertically opposite angles, and say this and this are equal. Therefore, using alternate angles, this and this will also be equal, as long as they are parallel lines. Okay, if they're parallel lines, you see these arrows here. Okay, this is the full figure. Okay, so I want to show you some examples. Okay, so here again, from what we did yesterday, okay, now this is my Z here. If you can watch, there, there, and there, and these are parallel lines as well. Okay, if they are not parallel, it's not true. But as long as we know they are parallel lines, then I can apply this Z thing. Okay, the alternate angles. So this angle here will be equal to this angle. So if I know this angle, I can say this angle is equal to this angle. And assuming I'm supposed to use this angle to find this angle, I can use the angle on a straight line, or I can use what we learned yesterday, vertically opposite angles, to find that. Okay, so this, I just wanted to introduce you to this and look at some example. So here, the first example is find A. So we found our Z here, and we know they are parallel lines. Okay, if they are not parallel, then it's not true. This is not to scale. Okay, so but they are parallel lines because of this line. So if this is 59, then A is 59. So 59 degrees. Okay. Now let's look another example here. So here again, they've drawn it differently. Okay, but that shouldn't confuse you because you can see two parallel lines going there. Okay, if you cover it again from what we did yesterday, this is what we're looking at yesterday: angle at the point, vertically opposite angles, okay, which are opposite. Now today we can look and say that with this second line introduced, that angle should be equal to that angle. That is my Z here. Okay, if you can watch the video for me. So this is the Z. Okay, so if this is 71, A here is 71. Okay, so straight away A is 71. Okay, so assuming I have a complex figure, okay, and I know this angle, I can use vertically opposite angles to find this angle, or angle on a straight line to find this angle here, because it adds up to 180. Okay, and then after I found the alternate angles, or the Z angle, this angle will be equal to this angle, which is 71. So A is 71. As long as they are parallel lines. If they are not parallel lines, it won't be true. Okay. Now let's look at our fourth example. Here again, two parallel lines. Okay, and we have a straight line. That is our Z here, from here to there, down and there. Okay, so sorry. So they said we should find A. Okay, so this is 48 degrees because there are alternate angles here. Okay, A here is also 48. But from what we learned yesterday again, if I cover this part, if I cover that part here, okay, that becomes a vertically opposite angle. So with the knowledge of what we did yesterday, we can find the opposite, and then whatever we get, 48 at 48, okay, we add them together, take that from 360, divide by 2, and that will be this angle here, and that will be this angle here. But because of the second parallel line, okay, that is our Z here. So if this is 48, A here is 48. So straight away, A is equals 48. Okay. I'm introducing you to this very slowly because angle work, as simple as it looks, it can confuse students. Okay, so yesterday I showed you this, okay, without this parallel line. Okay, let me cover this. Okay, now today I'm introducing this line and I'm showing you how. So with just one angle given, you can find the other angles. Okay, now let's look at this example here. So another shape, but it's parallel, and that will be our Z, even though it is a Z in another form. Okay, this will be our Z. So straight away, it's like they put something on the table and then they put it under the table. So you might have to turn your head upside down to see it. Okay, so now this is a Z here. Okay, so this angle 71 degrees, okay, will be equal to A. So straight, because they are parallel. Assuming they are not parallel, then we have to use a different concept. Okay, but these ones are parallel. So using alternate angles, or Z, and if you can remember the name, remember this a figure Z. Okay, so now with this, you know that this angle A equals 71. So straight away, A equals 71. So even if you've not been given asked to find this, and you've been asked to find this angle here, you should be able to use this knowledge, find this angle, use this knowledge to find this angle here using the angle on a straight line or the angle at the point. Okay, now let's look at this. Okay, now our Z here is turned in another form. Okay, because they won't give it to you for you to see, and the arrow is going down. Okay, so A here again will be 39, because I can find my alternate angles. That's my alternate angles here on my Z figure here. Okay, so 39 degrees here will be equal to 39 degrees. So straight away, I should be able to say, if this is 39 degrees, then A is 39 degrees. Because the chances are they will give me a figure, a complex figure, and I should be able to see where the parallel lines is. I should be able to find the Z, or look at the straight line and look at what angle I have, to use angle on a straight line, or vertically opposite angles, or angle at a point. Okay, so far we've learned a lot, okay, on angles. This is our third lesson, so we have enough knowledge. So even if I'm given this angle and I've been asked to find this angle here, I should be able to use this knowledge to find that. So if this is my alternate angle on my Z, then if this 39, then that will be 39. So this will also be 39 from what we learned yesterday. But today we are just finding this angle. So A equals 39 degrees. Okay. Our last example. Okay, again, they are parallel lines because we know from these two arrows. Okay, now the Z is from here. Okay, it's not like it's an opposite Z. Okay, if we turn it upside down this way, we can see it properly. Okay, but they want you to find it. Okay, so here, find A again. That is 69. So straight away, this A should be 69. Okay, so assuming they gave us just this angle, okay, and we are supposed to find this angle here. Using this Z here, we know if this 69, then that will be 69. Then we can use that knowledge to say that if this is 69, then that will be 69. we add them together and subtract from 360, divide by 2, then we can find these two angles. Okay, if there are more figures here, we should be able to use that to find whatever angle. So just by the few things we know now, we should be able to use them to start solving angle questions and doing some angle work. Okay, so today, that will be our last example for today. So today, I have done a recap with you for what we did yesterday using the vertically opposite, and then in the introduction where we said the angle at the point is 360, which we applied yesterday to do this vertically opposite angles. Okay, I've done some stuff on with you with dividing fractions. Please don't forget that, because there are chances you will need them. And then I've introduced you to alternate angles, or the Z angles, where you have parallel lines. As long as it's a parallel line, it is true. Don't apply this when they are not parallel lines. Okay, and then we've done some examples. Okay, we've looked at some examples, parallel lines in different shapes and form. Okay, we've done that. So I've brought you parallel lines but going in different directions, where we've managed to look at the Z. Okay, if you can look at the video, follow my notes whilst you watch the video, it will help you a lot. Okay, so that is what we have. So thank you very, very much for watching today's video, and I'll see you in the next.